Good morning. Happy Star Wars Day. It is officially May the 4th. So May the 4th be with you. Huge fan of Star Wars, so if you have time today, I highly recommend watching it. Oops. So last week we talked about molarity. We talked about using molarity as a conversion factor, and we also talked about some characteristics of acids and bases. Now, a lot of you might be thinking, well, how do we know if a solution is acidic, basic, or neutral? And there's a couple ways that we can do that. And essentially what this is saying is like, how do we figure out if I have a clear solution right in front of me? It could be an acid, it could be a base, it could be water, we don't know. And so there's a couple ways that we can actually figure that out. And the first way, happy week 4, the first way is, too far, is through an indicator. Now, an indicator is a chemical that will turn a specific color in acidic, basic, or neutral conditions. It depends on the indicator. It depends on the conditions. But the colors that you see and at what point or what acidity or basicity that indicator changes, that depends all on the indicator. So here's some common indicators that we would have used this year that you would have been able to see. The first one, which is the big one, phenolphthalein. So there's a pH and a TH in there. That's an interesting word. So phenolphthalein will stay clear on pHs 7 or lower. So if it's an acid or if it's neutral, it will be clear. As soon as it turns basic, it'll turn pink. We use these things in titrations in a lot of different labs. Our second indicator, which you might have seen before if you took general science here at Woodland High School, maybe even biology too, is this bromethymol blue or bromothymol blue. Usually your science teachers might call it BTB. This is an acid or this is yellow in an acid. It's green when it's neutral, and it's blue when it's in a base. And so this is kind of, if we just put a couple drops of bromethymol blue, then we'd be able to say, oh, this is an acidic solution because it's yellow, or oh, this is a basic solution because it's blue. We won't know how basic. It could be really, really basic. It could be slightly over neutral. We wouldn't know. And then the last one, there's this thing called the universal indicator here. This is what is on your pH strips. This is also, if you've ever used red cabbage as an indicator, that's a natural indicator. It'll also kind of show this color scheme too. Now, this is a very obviously rough outline of what this universal indicator can do. This is all a spectrum, essentially. Okay, but those are indicators. They change a specific color in a specific condition. The other way that we can figure out if it's an acid or a base is via pH, and I kind of noted it up here, but we also have, pH and pOH. So a pH scale is a way of expressing the strength of acids and bases based on the concentration of H+. Now, we learned a little bit last week that concentration is the same thing as molarity, and molarity is moles of something over liters of solution. So we're saying in a solution of this acid, we're looking at the specific concentration of this H+ ion. Remember, these brackets here also mean concentration of H+, just like this does. So how can we do this? When we put an acid, like hydrochloric acid, in water, it will dissociate. And when something dissociates, it means you split up into its ions. So when we put HCl, it'll kind of separate into H+ and a Cl-. Now, it's in water, and so aqueous, we need to remember, is another way that we can say, oh, everything is in water. An aqueous solution means we have a concentration of H+ and a concentration of Cl-. So again, we're putting hydrochloric acid in water. And remember, just this kind of note for you right here, is that when we have a concentration of H+, that means we have a molarity of H+. That means we have moles of H+ over liters of solution. So let's talk about the pH scale. What does it look like? I'm going to scroll too far. Put me over here. There we go. So what does it look like? pH scale, it goes from 1, sometimes 0, all the way to 14. If we're looking at this one over here, we can see that we have things like hydrochloric acid. We have lemon juice over here, which is about at a 2. Vinegar, which is acetic acid. We talked a lot about these examples last week. We get in the neutral zone, and there is a zone of neutral. Everyone thinks that, oh, exactly at 7, if I have a pH of greater than or less than 7, it's not neutral anymore. No, there's a range, and usually scientists consider neutral to be anywhere between 6.5 and 7.5 to 7.8. And so this is kind of our neutral zone. That's where we have milk, we have water, we have our blood. Notice it's slightly basic, but it's still within that neutral zone. You can't really see, this is a purple highlighter here. You can't see that very well. But these colors here show you the universal indicator colors at specific pHs as well. But we have a base if it's anywhere between 14 and we'll say 7. It's neutral if it's at 7, and we have an acid if it's 7 to 1. So that's our pH scale. So how on earth do we calculate pH? Yes, we can calculate it other than just sticking a pH meter in our solution and reading the number. We can calculate it based off of a certain number of things. And before we can calculate pH, we need to learn about this thing called logarithms. If you've taken, honestly, I don't know when you learned this. I think Algebra 2. If you've taken Algebra 2, then you know what a logarithm is. But for those of you who haven't, a logarithm essentially is an inverse of an exponent. So it's the opposite. It's the flipped over version of an exponent. And really what it's asking is how many of one number do we multiply to get another number? That's the essential question that we're asking here. So example, how many times do I multiply 2 by itself to make 8? Right? So I have to cube 2. I have to do 2 times 2 times 2 in order to get to 8. And we had to multiply 2 3 times to get 8. That means 2 cubed is equal to 8. The logarithm is 3. I had to multiply 2 3 times to get to 8. And the question is, how many of one number do we multiply to get another number? That means our logarithm is 3. Now when we write our log, what we see is that log base 2 of 8 equals 3. What on earth does that mean? Well, if I multiply 2 3 times, I will get 8. Or I need to multiply, how many times do I need to multiply 2 together to get 8? Well, that answer is 3. That's a logarithm. The same thing happens with pH, but our base is 10. So our concentration of H plus is equal to 10 to the negative pH. So when we do the inverse, we do our logarithm, we have, because this is negative, we bring the negative out front, we have log base 10 time of the concentration of H plus will equal our pH. Or in order to multiply 10 by so many times to get this concentration of H plus, I need to multiply 10 by itself this many times to get H plus. So these are kind of like your money equations here, these two. Now you don't necessarily have to understand logarithms to be able to do these calculations. I'm going to show you on my phone. On your calculator on your phone, you do have a logarithm button. And you'll see that it's log, we call it base 10. Let's see. There it is. So on your calculator, you can see this log base 10 button. That's going to be your friend when doing calculations. Maybe you have a different calculator. Look for that log button. Make sure it's base 10 at the bottom. If you have questions, just email me. Let me know. I can help you figure out your calculator. But like I said, you don't necessarily need to understand how to use logs or what a log is. You just need to know how to use it in this context. Okay, so let's look at this example right here, example number 1. Remember, my notes are labeled example number 1 so that if you have questions, email me and say, hey, I really didn't understand why you did this move in example 1. I'll be able to help you, no problem. So the pH of an unknown liquid is 3. What is the concentration of H plus? Is it an acid, base, or neutral? So I know automatically that I'm given a pH, I want to find H plus. So I'm going to use this equation right here, that my concentration of H plus is equal to 10 to the negative of my pH. So that means that H plus is equal to 10 to the negative 3. And I type that in my calculator, or I know how to do how to solve exponents in my head, whatever. And I should get 0.001 molar H plus. Okay. Now I don't look at this number and say, oh, it's an acid or it's a base or it's neutral. I'm going to look at the pH again. So the fact that I know that I have a pH of 3, that is less than 7. And so I'm going to have an acid. Right here, pH of 3 is less than 7. It is an acidic solution. I'll make this a little smaller. Okay, that is example number 1. Example number 2, we're going to kind of do some opposites here. So if the concentration of H plus is equal to 2.5 times 10 to the negative 10th molar in a solution, what is the pH? Is the solution acidic, basic, or neutral? So in example 1, we had the pH and we needed to solve for concentration. This time we have the concentration and need to solve for pH. And so we're going to use this pH is equal to the negative log base 10 of H plus, concentration of H plus. So my pH, I'm just going to plug this in because I have this number right here. And I'm just going to take this number and plug it right into here. pH is equal to the negative log base 10 of 2.5 times 10 to the negative 10th. Now, when you're doing this in your calculator, it depends on what calculator you have, but your order of operations kind of matters. So what I'm going to do, since I know most of you use your phones as calculators, what I'm going to do is I'm going to show you how to do this properly. So the first thing that you're going to need to do on your phone is to type this number here. So this guy goes first, this 2.5 times 10 to the negative 10. 2.5, remember, times 10 to the is equal to the EE button. Right there. So I'm going to push that EE button, and that tells my calculator that I'm doing a scientific notation. And then I'm going to push 10 because I don't have a negative button, and then I'm going to push negative. So right now I have this number typed in, 2.5 times 10 to the negative 10. I'm going to push equals because my calculator does that, which is fine. It means it's the same thing. And then you're going to go and push the log base 10 button. And I get this number here. Now remember, it's the negative log. And so I'm going to push the negative button again. And I know that my pH should be 9.60 to blah, blah. We could keep going. But if we round it, 9.60. Okay, so I kind of went fast through that. I apologize, but pause me, slow down, rewind, and you'll be able to figure out how to use your calculator. Other calculators look slightly different, and you just need to type it in a slightly different way. Again, if you're like, I have no idea how to use my calculator, let me know. I'm pretty well versed in most calculators, so you just need to tell me and I'll be able to help at some point, or at least help you figure it out. Okay, so we did our pH is equal to the negative log base 10, 2.5 times 10 to the negative 10 molar. We got pH is 9.6. Now, 9.6 is greater than 7, and so we have a base. Okay, now you see this little arrow here. This 10, we don't have to write this all the time. We can just remove the log. And from this point forward, I believe that I don't write this 10 here. This is just saying that I'm multiplying 10 so many times to get this number. That's all it is. But when we're doing pH and concentrations of H plus, it is always base 10. All right. There is a PDF of these notes on Google Classroom as well, actually attached to the same assignment. So make sure you're at the very least printing this out, or you're copying or you're writing along with me. Okay, so we have a pH scale. We also have a pOH scale. The pOH scale is a way of expressing the strength of acids and bases based on the concentration of OH minus. OH minus, hydroxide. Our hydroxide ion is important, and we know that because in our Arrhenius acid and bases definition, the bases produce an OH minus. So the pOH scale is kind of the opposite of the pH scale. So on the pH scale, if you have a pH of that's less than 7, that's going to be an acid. Well, in the pOH scale, that is a pOH of greater than 7. If I have a neutral, they're both the same, which is nice. Neutral is for a pH scale is 7. Neutral for a pOH scale is also 7. But when we get to base, the pH scale is greater than 7. That's a base. But the pOH is going to be less than 7. So we're measuring the concentration of OH versus H plus in our solutions. So bases dissociate in water just like acids do. And we can see here in NaOH that it splits into Na plus and OH minus. So we have that concentration. Now, hopefully I can get this scale on the entire page. Close enough. Okay, so here on this side I have my pOH scale. Here on this side I have my pH scale. My pH scale shows you here that if I have a pH of 14 to 7, I'm going to have a base. If it's around 7, it's neutral. 7 and below or 6 and below is going to be an acid. But in the pOH, if I have a constant, like a pOH of 14 to 8, that is an acid, right? If I have 7 again, it's neutral. But if I have 6 or below, it's a base. So they're opposites of each other. And you kind of have to remind yourself that. But how do I calculate pOH? Pretty much the exact same way that I calculate H+. So we're looking at concentrations and we're looking at the inverse of an exponent. And so it's just a scale that we're looking at. So remember our calculations for pH before where pH is equal to the negative log of H+. Well, pOH is equal to the negative log of OH minus. And our concentration of OH minus is equal to 10 to the negative pOH. We solve these problems the same way that we would solve the H+ or the pH problems. So example number 3. What is the pOH of a solution with a concentration of OH minus equal to 5 times 10 to the negative 3 molar? Is it an acid? Is it a base? Or is it neutral? Now we're given OH minus right here. So I'm not going to use this one. I'm going to use this equation right here and plug in my number, 5 times 10 to the negative 3, into my negative log. And when I calculate that out, I will get my pOH is equal to 2.3. Now, it's equal to 2.3. That is less than 7 on the pOH scale. That means that it is a base. Okay, so we need to remember that a pOH scale and the pH scale are different. All right, moving on to example number 4. Same thing. Example number 4, what is the concentration of OH minus of a solution with a pOH of 11.5? Is it an acid? Is it a base? Is it neutral? Now this time we're given the concentration, or no, we're given the pOH. We want to find the concentration. So if we have to pick between these two, we want this. So I'm going to use this equation here. Okay, so I use this equation. I plugged in my pOH, which is 11.5. Remember to make it negative. You have to make it negative. That's going to mess you up if you do not make it negative. And I calculated this out and got 3.16 times 10 to the negative 12 molar. Now, this is my concentration of OH minus. Now, if I'm going to figure out if it's an acid, a base, or it's neutral, then I'm going to go back to my pOH. I notice that it is much greater than 7, and so it's going to be an acid because, again, I'm dealing with my pOH scale, not my pH scale. Okay, so we've been talking about how they're kind of the opposites, and that really has, and how they relate to one another is what we're going to get to next. And that's because anything dissolved in water has both H plus and OH minus. Why? That's because the dissociation of a water molecule looks like this. I have H2O, it will split up into H plus and OH minus. But look, there's that equilibrium yield sign again. So that tells me that I will have an H2O, it'll split up into H plus and OH minus, and then they'll come back together again and make H2O. And they'll split up, and they'll come back together again and make H2O, and then they'll split up again and come back together. And so it's just this reaction going backwards and forwards at the same rate. So again, when it says at the same rate, it's saying that for every H plus and OH minus I make, another OH minus and H plus somewhere is going to come together and form another water molecule. So I'm making this as often as I make this. Right, equilibrium. So what's cool about this is when we have an acidic solution, so I put HCl or hydrochloric acid in water, I'm going to have an upward spike of H plus ions because I'm adding H plus ions. So my acidic solution is going to have a higher concentration of H plus than OH minus. Now, if I just leave it normal, that means that our H plus and our OH minus are going to have roughly the same concentration. And so that's our neutral solution. That's water. Now, in a basic solution, if I added a base like NaOH, then I'm going to have an upward spike of OH minus ions in my solution. And so I have a basic solution when my concentration of H plus is greater than my concentration of OH minus. Now, most of the time, we don't know what our concentration of either one is. We can figure that out using pH and pOH, though. So in water alone, what's really cool is that H plus equals OH minus, and that is equal to 1 times 10 to the negative 7th. Well, if you figure that, if you look at the pH of 7 or a pOH of 7 and solve for the concentration, you'll see 10 to the negative 7. And so this happens. If you want me to prove that to you, I absolutely can. Just send me an email. So when we multiply these two concentrations together, we get this really cool thing here. H plus times OH minus equals 1 times 10 to the negative 14th. Now, through some math magic, that's what this arrow is. Again, I can show you if you want me to, but magic, we have pH plus pOH is equal to 14. And this is kind of how these two concentrations are related. And we can use this to our advantage mathematically as well. So if we know one value, if we know pH, if we know pOH, if we know H plus or OH minus those concentrations, we can calculate the other three, which is useful because I need to use this plus my other equations as well. So let's look at example number 5. What is the pH of a solution with a pOH of 12.5? Is it acidic, basic, or neutral? I can just go up here and use, I have pH, I want to know pOH. There's one equation in our list of equations that uses pH and pOH, and that is this pH plus pOH is equal to 14. And then it's a simple, I'm going to rearrange my equation. I'm going to subtract pOH from both sides, and I have pH, that's to get pH by itself. And I'm going to have pH is equal to 14 minus the pOH, which is 14 minus 12.5, and that's equal to 1.5. Now, in order to determine if it's an acid, you could look at either one. You could say, oh, my pOH is much greater than 7. According to my pOH scale, it's an acid. Or you can say, my calculated pH is much less than 7. According to my pH scale, that's an acid. So it'll tell you the same thing. Example number 6, what is the concentration of OH minus of a solution that has a pH of 5.8? So there are many ways that we can solve this problem. Here are 2 ways. These are the 2 most kind of legitimate ways that you should be solving these problems. But what I want you to notice is that this question wants us to find the concentration of OH minus, but it gives us pH. So if I'm looking through my list of equations, my pOH is equal to the negative log, my pH is equal to the negative log of H plus, there is no equation that directly relates those 2 values until I get to these equations up here. These equations up here will help us. So the first thing that you have to do is figure out the concentration of H plus. Or this is the first way that you do it. So I found the concentration of H plus first, using my 10 to the negative pH. I found my concentration value, and then I used H plus times OH minus is equal to 1 times 10 to the negative 14th. 1 times 10 to the negative 14th. So we can arrange this. And I'm going to divide by, I'm going back up here, I'm going to divide by H plus on both sides. Cancels out over here. and I should get OH minus is equal to 1 times 10 to the negative 14th over H plus. That's this guy right here. So I just rearranged my equation. Same equation, I just moved it around a little bit. And then I know my concentration of H plus is equal to 1.58 times 10 to the negative 6 because I calculated that right there. And so here's my concentration of OH minus. Now you can do this the other way. Maybe you thought of this and said, oh, I'll just do pH minus pOH. You can absolutely do that too. Here I have my pH plus pOH is equal to 14. I rearranged my equation to get pOH is equal to 14 minus pH. And then I can find my pOH, which is equal to 8.2. Now, in order to find my concentration of OH minus, I take my OH minus is equal to 10 to the negative 8.2, and I'll get the same answer. So either one of these methods are valid. You can do either one. We got the exact same answer, and so whichever way your brain thinks, both are correct. Neither one of them, if you put, this method instead of this method on a quiz or something like that, or on a practice homework, I will not mark you wrong because technically you solved it in a very valid way. Okay, so that's so far our examples have been pretty easy. We're either given concentration or we're given pH or pOH, but sometimes we don't get the concentration in our problem. So these can be a lot more difficult. In a lab, we never get the concentration. We have to calculate it ourselves. We have to measure the gram amount of an acid or a base and dissolve it in a known amount of water, so I know how many liters of solution I have. So yes, we're going back to stoichiometry because it never goes away. So sorry. So example 7. Example 7, a lab aid dissolved 0.04 grams of NaOH in a 1 liter solution. What is the pH of this solution? Now we have a lot of equations kind of given to us, which is nice. I put down the ones that I thought we were going to need to use. Like I need to know the pH, which means I'm going to have to know a concentration of H plus, or I'm going to have to know what the pOH is, or I'm going to have to use this. So there's a lot of different things that we could use here. But I wrote out what I was given, which is 0.04 grams of NaOH. I know that. I know my liters of solution. I need to find my pH. So here's what I was talking about before. We need H plus or pOH to find pH. Now, these are kind of labeled in steps 2A and 2B, and you'll see why in a second. But let's just go forth and start solving. So either way, in order to find my concentration of H plus or my pOH, to find my pH, I need to first find my concentration of OH minus ions, which is the first step that I did. And the reason why I said concentration is I'm given a gram amount. Our concentrations are in moles per liter, so this is what we need to do. This is my molar mass of NaOH right here. I used this balanced chemical equation right there. NaOH will dissociate or separate into Na plus and OH minus. Lucky for us, it's a 1:1:1 ratio. But it's important to note that we're looking for OH minus here, not NaOH total. So I have my grams to moles conversion, and then I do moles of NaOH to moles of OH minus, and I'm given, and I'm given 0.001 moles of OH minus. Well, that's not our concentration yet. In order to find our concentration, we need to divide it by our liter of solution, and we know that because it was given to us up here in the problem. So I have my liters of solution, I have my moles of OH minus, and when I divide those two, I get a concentration of 0.001 molar OH minus. Okay, so I have my concentration. Now there's two ways that we can go. We can find the concentration of H plus, or we can find the pOH. Either way is valid and will help us get to the pH. So let's look at this way first. Oh, wait, no. Whatever. Let's look at this way first. So I have I'm going to put me over here so that you don't get distracted. Okay, so I have my H plus here. I'm going to use this equation. Again, it's this times this equals this. I just rearranged the problem. And I'm going to find that my concentration of H plus is equal to 1 times 10 to the negative 14th divided by 0.01 molar OH minus. And that will give me 1 times 10 to the negative 11th molar H plus. I'm not done yet. The question wants me to find the pH. And so my step 3A, kind of in this corner here, means I'm going to calculate pH using H plus, and my pH is equal to my negative log of H plus, which will get me to a pH of 11. Perfectly valid, right? Now let's go over to 2B. So we already figured out that our pH is equal to 11, which makes sense because NaOH is a known base. We just wanted to know how basic that solution was. So if I look here, I can find the pOH. My pOH is equal to my negative log of concentration of OH minus. Now we found that already up here in this step. And I can find out that my pOH is 3. Now I can use my pH, or calculate my pH using my pOH. And I'll have pOH, we'll go down here. pH equals 14 minus pOH. Now remember, I'm just manipulating this equation here, something that we should be familiar with. And then my pH is equal to 14 minus 3, which equals 11. Oh my goodness, they have the same answer. So either way, both of these ways are completely valid. You could have done it any way that you'd like, but you needed to start by doing a grams to moles conversion. So stoichiometry came into play here. Also, here comes molarity, which is what you learned last week. Now, all these numbers were nice and easy. You cannot expect that all the time. So that is it for calculating pOH and pH. That is everything that we're going to learn when it comes to determining acids and bases. Make sure that you are writing these notes in your own notebook, and you're interacting with these notes. Email me if you have questions. Remember, office hours changed a little bit. So if you have questions or you need help on something, send me an email and I can set up a Google Meet so that you and I can actually talk to each other and I can help you through some problems. Remember, I don't expect you to be able to do this completely on your own. You are not on your own. Just email me with some questions and I'll be happy to help. All right. It was fun learning with you. Happy learning. Have a good week. Happy Star Wars.